In this video, we're going to be looking at some trends that occur within the groups on the periodic table. The groups that we're going to be looking at are the alkali metals, the alkaline earth metals, the oxygen group, the halogens, and the noble gases. Let's start with the alkali metals. These are the metals in group 1A of the periodic table. They are all soft, metallic solids, so you can see that you can easily cut through them with a knife. These are some of the most reactive metals on the periodic table, so you're always going to find these as a compound in nature. You don't find them by themselves. And you can see in the picture the person's wearing a glove to handle them. These metals are highly reactive with water. There's a video in the resources section where you can see how exothermic the reaction is when you put them in water and how reactive the reaction is. The alkali metals also have low densities, low melting points, and low ionization energies. A few things to point out about this chart. As you go down the group, you can see that you're adding an energy level each time, as expected. You can see that the atomic radius is getting larger as you add that energy level. And the ionization energy is decreasing, which is what you would expect as you go down a group on the periodic table. Let's look at how the alkali metals react with oxygen. Lithium reacts in a predictable manner. You see that you make lithium oxide, and the atoms have taken their normal charge, as would be expected. Lithium is +1, and oxygen is -2. However, generally, sodium reacts with oxygen to form a peroxide. What I mean by that is instead of oxygen having its normal -2 charge, it's the peroxide ion, which is O2 with a charge of -2. That means each one of these oxygens has a -1 charge. Potassium, rubidium, and cesium also have a somewhat unusual reaction with oxygen. They form superoxides. A superoxide is O2, and the whole thing has a charge of -1. So each one of those oxygens gets half of a negative charge. So while most metals form oxides, sodium would form a peroxide, and these three elements low in the alkali metals form superoxides. The alkali metals, when put into a flame, will produce different colors depending on which metal it is. Lithium normally produces a red color, sodium a yellow, and potassium a purple color. What's happening is that the valence electrons, the electrons in the outside energy level, get excited by the heat from the flame, and they jump up to a higher energy level. When they fall back down, they emit different wavelengths of light, and you should see this in your lab next week. Even though hydrogen is in group 1 on the periodic table, it has very little in common with the alkali metals. Hydrogen has an ionization energy that is almost twice that of the alkali metals, so it does not lose its valence electron very easily. Hydrogen is a nonmetal, normally found as a diatomic gas in nature. The alkali metals, when they bond with nonmetals, they form ionic compounds. When hydrogen bonds with another nonmetal, it's going to form a molecular compound, like water. Hydrogen also has the ability to gain an electron, which is very different from the alkali metals. So hydrogen will be discussed much later in the second level of chemistry when we talk about acids and bases, but it does not fit in with the alkali metals. Moving on to the next group, group 2A, the alkaline earth metals tend to have higher densities and higher melting points than the alkali metals. They still have low ionization energies, but not quite as low as the alkali metals. And you can see that it follows the trend. Atomic radius increases as you go down the group. Ionization energy decreases as you go down the group. Just like with the alkali metals, these metals get more reactive as you go down the group. One example of that, beryllium does not react with water. Magnesium only reacts with steam, but as you go further down the group, these other alkali metals react very easily with water. So reactivity tends to increase as you go down a group. These metals have two valence electrons, so they tend to form cations with a charge of +2. These metals also turn colors when put into a flame. Strontium usually turns a red color, and barium usually turns a green color. Skipping over to the other side of the periodic table, let's look at group 6A. At the top of this group, you have some nonmetals, and they get more metallic in nature as you go down. Tellurium is a metalloid, and polonium is a metal. As expected, the atomic radius increases as you go down the group. Ionization energy decreases as you go down the group. Oxygen is often found in two forms, so we say that it has two different allotropes, which are just different forms of the same element. Oxygen is usually found as a diatomic gas, two oxygen atoms bonded together. But under some conditions, it's found as the O3 molecule, which we call ozone. O3 is usually found in the upper layers of our atmosphere and is very good at blocking UV light. When oxygen becomes an ion, it usually accepts 2 electrons and takes a charge of -2. But a few slides ago we saw some cases where it can become a peroxide ion, so you have O2 with a charge of -2, or the superoxide ion where you have O2 with a charge of -1. So those are just some different ways that oxygen can become ions. The most common way is for it to gain 2 electrons and take a charge of -2. As you go to the next group on the periodic table, you continue to go further to the right, so you see a higher ionization energy. This group is called the halogens. They're made up of nonmetals, and the halogens are normally found as anions, so they normally have a -1 charge. And you can see the reason for that in the electron configuration. They all end with a p5. Well, this p sublevel would be full with 6, so they're all 1 electron away from having a full outer energy level, so they tend to take that 1 electron from someone else and have a charge of -1. Very often they have reacted with a metal so that they can take that 1 electron away from the metal. And lastly, on the far right of the periodic table, you have your noble gases. These have very, very high ionization energy. You're not going to take an electron away from a noble gas. Noble gases all end in P6, except for helium. It doesn't have a P sublevel. It ends in 1s2. But they all have full outer energy levels. This makes them very unreactive, and they're usually found as monatomic gases. What that means is just one atom right by itself as a gas.